Okay, before we start going into R, we need to know how to set up R so that it reads the files from the directories that we're using. We want it to sort of do that easily instead of us having to always point to the proper directory. But anyway, let's take a look at this quickly. So here we have some data. We have age, weight. So we have age is 1, 3, 5, 2, and we keep going down to here. And weights are here, 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 and so on. And these are supposedly the age and weights of 10 babies. So we go down here and here for the ages and the corresponding weights. So we can enter these as vectors, and we've already learned how to do that. So the ages are what? 1, 3, 5, 2, 1. So you see 1, 3, 5, 2, 11, and so on. And weights are here. So go ahead and start up R and enter this data. So pause the video and enter the data. Okay, so you're creating two variables, age and weight, which are both vectors, and you can, after you enter it, you can test to see what you have, like this. So I did age and weight, so I can check age and weight, like that. So you can check that, and then calculate the mean for both of these. So calculate the mean for both of them. And we can also do something like this. I think we saw this before. This is called the standard deviation, something in statistics, which tells you how much variation there is in the weight variable. So if I look at the weight variable, you can see that the highest value is about 10.4 and the lowest value is maybe, which is the lowest value? Maybe this one, 4.4. So there's a kind of variation of about 4.4 to 10.4. Standard deviation measures the variation also, but in a different way. So if we look at the standard deviation and the weight, so check that just to see if you can do it anyway, even if you don't know what it means exactly. But the standard deviation is called, it turns out to be what is 2. Okay, you can do that. Now, this is interesting. This is the correlation between age and weight. So what I mean is, as age increases, does weight also increase? Or not? Maybe age and weight are not related at all. Of course they should be. If these are babies, the older they are, probably the more they weigh. But anyway, we can check to see that. And if when we do this we get 1, that would mean they're perfectly correlated. But if we get 0, it means that they're not related at all. And if we get -1, it means that they're related but inversely. That is, if age increases, weight decreases. So anyway, we can try it. Okay, now let's talk about the workspace, which is very important. This is how to manage your sessions so that you can come back to them and see what you were looking at before, and set the directory where you're working and things like that. It's very useful.